Welcome to People in Innovation, a CPI podcast. From groundbreaking discoveries to the challenges behind the breakthroughs, we shine a light on the people behind the innovations that are shaping our future. I'm Steve Bagshaw, Chair of the High Value Manufacturing Catapult, and your host for this series. In our last episode, we explored what engineering biology is and why it's being called the next industrial revolution. But how do we actually turn biological design into commercial reality? A recent report from the House of Lords, Don't Fail to Scale, Seizing the Opportunity of Engineering Biology, warned that while the UK leads in research, it risks losing its competitive edge unless we help companies scale here in the UK. Today, we're looking at that journey from DNA to product and how partnerships between innovators and organizations like CPI make it possible. I'm joined by Alex Smith, Director of Biotechnology at CPI, and Dan Wallis, Production Operations Manager at Azotic Technologies, whose natural nitrogen fixation technology is helping farmers reduce reliance on chemical fertilizers. So before we get into the detail, I'd like to invite you both to introduce yourselves and share a little about your work and how it connects to scaling engineering biology. Alex.
Hey, thanks, Steve. Hi, I'm Alex. As Steve mentioned, Director of Biotechnology at CPI. In terms of my background, I'm a process engineer. I've spent most of my career doing process engineering. Interestingly, started out in a very different world. So I started out in the world of iron and steel, sort of very traditional old technology. Did that for the first kind of half of my career, and then moved on into CPI from there. It's a very interesting move from that world into this world, the very, I guess, relatively speaking, very dirty world into a much cleaner world. And also the change as well for me from the again, that very traditional old school industry into a world where everyone's trying to do new things, everyone's trying to do things differently, trying to find better ways to do things is always super interesting. Yeah,
brilliant. Thanks, Alex. Dan, how did you get into this world?
Morning, Steve. Thank you. I started my career in chemicals, coming as an apprentice on Teesside, and then moved actually across to CPI. I started my career in biotechnology with CPI back in 2012. Having spent nearly 10 years at CPI, scaling up and working on different fermentation processes alongside many different customers, I joined Azotic in 2022, which is a very different world, a lot more commercial facing, and working with a microbe to try and help face some of our issues that we face in the world.
Brilliant. Well, thanks both. I mean, that sounds, both of you have got some really interesting experiences that I'm sure we're going to get into. I want to start at the beginning, though, of why is engineering biology so challenging? And why do so many companies struggle to actually get from lab to market? Alex, you said you started in a very different world. What's different about engineering biology, and why is it so tough?
I think that there's a lot of kind of added complication with kind of bioprocess scale up when you compare it to more traditional standard process chemistry type scale up exercises. Fundamentally, the fact your process is alive is a big factor there. You've got the added challenge of, keeping it alive, keeping it happy, making sure nothing from the kind of the big bad world gets into your nice, carefully curated, sterile environment that you've constructed for your organism. There's also just the predictability of it as well. Things don't always behave, exactly how you would expect them, and some of the factors that influence that can be significantly affected by scale as well. And yeah, it's definitely interesting.
Dan, from your world, when people ask you, why is it so difficult? What do you put your finger on?
Yeah. So to follow on from Alex, I think from my side, I think it's the consistency and how we can repeat these fermentations. For example, what we always talk about from a commercial standpoint, we have a win rate of around about 75% is what we predict across the year. So if we're doing 10 fermentations across the year, we're predicting that only 75% of the fermentations might work. Like Alex, in the chemical world, it's a little bit different. So it's being able to make sure we can get that repeatability and create consistent products.
What makes it so difficult? What's at the core of why 75%'s desperate, isn't it? I mean, if you imagine that's 3 months of the year that you're basically doing stuff that doesn't actually work out in a 12-month year. So what is it that goes wrong?
This is it. So from a KPI basis, if I manage to get 100%, it looks good on us and the team. But we have to go in with that mindset at the start of the year, because the type of thing, if you get contamination, from a regulatory standpoint, we cannot have contaminations within our product. And ours is going on to a field. I know that Alex, in some customers that he works with at CPI, contamination is absolute. There's no way they can move on, and it's one of the big things that causes us challenges. I'm trying to think of some of the other ones. You've got one of the big challenges is understanding the bug, having the technical ability to understand the fermentation, operators that understand fermentation, the resources that are available to be able to manufacture these products.
Yeah, I think it comes back to me to the whole it's alive thing. Like, chemistry is quite predictable from an engineering point of view. In chemistry, things generally like to follow the laws of physics, so you can be pretty confident in your predictions of, if something did something last time, it'll do it next time. It'll do the same thing every time. In a bioprocess, organisms can be quite moody things. They don't always behave predictably. They've got a bad habit. Some of them, for example, will generate and excrete things that under stress that are actually harmful to themselves. So they end up swimming around in a soup of stuff they don't like. Sometimes these things happen as a result of, things you only really see for the first time when you get to a larger scale. Things like poor mixing, for example, or poor control of certain variables like temperature, things like that, which are just inevitable at large scale compared to a lab. It's you have to be there to see the problems.
Yeah, you're painting a picture that makes it sound quite difficult to get any of these right. I'm imagining though, when if you're fermenting in a more predictable way, so presumably it's not 75% success rate if you're making beer or something like that, is it? Presumably you're talking about, this is one of the problems with really at the beginning of characterizing a fermentation and trying to get it right, because you're at the beginning of trying to work with these bugs or whatever it is that you're using to create the product. Presumably one of the issues is you actually are stepping into the unknown in some of these areas, particularly, Alex, the ones you work in. Dan, I assume because you're doing it more repeatedly now, you would hope, I assume, that as time goes on, you'll up that success rate, will you?
Absolutely, yeah. But again, although we constantly look to increase that success rate, what Alex is talking about, the challenges are becoming temperature. You've got a live organism in there. You have an increase in temperature or drop in temperature, it's affecting the performance of the fermentation. It's affecting what you get out the other end. For us, then, what's happening is then products are going from what we manufacture here at CPI into the market. We have to be able to create consistent performing products. People adapting to taking biologics into agriculture is already difficult. If we have inconsistent products in the market, it doesn't really help our story.
So we've talked about the technical issues you've got. So are there other issues that are particularly seen in engineering biology? I'm thinking more about when people talk about the valley of death, they don't necessarily think about technical hurdles, I don't think, as being the ones that nail you before you get to market. That's only one of the reasons you can fail. What are other reasons that are particular to engineering biology?
This is a really interesting topic at the moment. Fundamentally helping companies across the valley of death is what CPI and the Catapult Network's here to do. Interestingly, now though, we're hearing, we talk a lot more about it's not just a valley of death. There are several points at which you can there are situations where you can fail. and you need help across these areas. Fundamentally it's two values we really see from a bioprocess scale-up point of view. The first is the traditional one that we've always spoken about, the technology development, moving your process out of the lab and into an industrially relevant environment and scale, and making sure it works robustly in that environment. And then the second is actually then taking that and commercializing that and taking that to a point where you have a product on the market, you are a successful business. And this is part of the reason why, as a business, we focus on, it's not just scaling technologies, it's on creating businesses and commercialization and helping people through the whole element of that journey. It's not just about, running your process in a larger pot and then you're there. You have to have a viable business. You have to make sure you've got the right networks, the right supply chain, the right business plans, the right people involved in delivering in running and delivering your business, to make sure you have the best chance of making it successful once you have a technology that is ready to be delivered at a commercial scale.
That's great. And Dan, from Azotic's point of view, where are you versus the two sort of valleys that Alex is talking about?
Yeah, we're absolutely in the second. From a technology standpoint, like I say, the collaboration, the working with CPI started around about 2019. Between Azotic and CPI, I strongly believe we got over the technical issues. They're now behind us. Again, we'll work on this percentage of win rate, but the technical issues we're in now this second phase, a bit like what Alex is talking about, is the adaptation and people taking biologics into the market. And again, a bit like what Alex is saying, from a fermentation standpoint, it works great in the lab. We often hear all these things, it works great in the lab. We scale it up, we get it working great at 10,000 litre scale. However, for Azotic, then it's important that it's consistent in the field. We know how much nitrogen fixing can help some of these challenges. We know that we're not here to take over synthetic nitrogen fertilizers. We're just here to help and support. But from a scale-up standpoint, it's being able to get the right supply chains, get the right partners through, like you say, partner in CPI with Azotic. We have other partners that help us manufacture products along the way. From a small startup business, the different challenges that you face. For example, for my situation, I left CPI in 2022, joined Azotic. My background was always fermentation for 10 years, and then it's understanding how the packaging affects biologics, the storage conditions, the supply chains to get out to different distributors globally. All these other challenges then come along through the scale-up journey.
That's interesting, and I guess, Dan, it would really help us all if you've talked about nitrogen fixing there. Just in a nutshell, what does it do? What's Azotic's product actually do?
So what Azotic's looking to do is create a microbial solution to reduce the need for synthetic nitrogen fertilizers. Our product is, we've got a couple of products out there in the market now globally that are helping farmers to reduce their need for synthetic nitrogen fertilizers. We can help to reduce it down. We're seeing results in the field where farmers are reducing down from 100% to 75% to 50%, and we're seeing results in different areas across the globe where people are looking to reduce down and help to support it with our biologic products.
That's really interesting. Well, thanks for sharing. And I think there's probably going to be a couple of questions coming up where we talk a little bit about adoption and some of the problems of getting adoption as well. But for now, I'm interested, Alex, going back to what you were talking about. You talked a little bit about how CPI helps companies in a more holistic way than just the technology. I wonder if you could just say a little bit about some of your experience of where companies struggle in that area. What are the areas that you think CPI is particularly set out well to help companies with in that second valley of death?
I think for me, we've built our team specifically to have a balance of sort of academic and industrial backgrounds. So I've come from a purely industrial background myself. Others in the team have come from a more academic background. So we sort of speak both languages, understand both worlds, understand that, how to translate between science and engineering, and how to translate between science and engineering and business, helping people to understand the things like what Dan was saying there. Make sure you've got a supply chain and make sure you've got the right people. The right people is a really big part for us, because a lot of the businesses that we work with, there might just be 2 or 3 of them. There might just be a couple of people in a spin out from a university. They are extremely good at what they do, but there are significant gaps in what those 2 or 3 people can do. So we sort of try to be the gaps until you can fill them yourself. We've actually, in the past, we have even helped people to, identify people to bring into their teams. For example, if you have a scientific-led, most of our customers initially are scientifically led, recognizing that if you're going to go and then commercialize that, you're going to need some engineering input, for example. Help to bring in the start of that engineering team, and we'll help to sort of help people to understand who to bring in, what the right type of character, right type of background, right type of experience to help build that capability for themselves. I never remember whose quote this is, but we always sort of say, when you don't need us anymore, we've succeeded, we've done our job. And that's where we're trying to get to, is help people to build themselves up and build their businesses up to a point where they can survive on their own. It's not for us to sort of stay hanging on to people forever. We're trying to transition people out into the market, help them to build their teams, build their right networks. And that's an important point as well. It's not always about recruiting internally. It's about building a network, finding out who your collaborators are, who you should be working with to help you to get where you need to get to.
I mean, that sounds really positive, and it sounds like a really good part of the response, if you like, to the House of Lords report that I quoted at the beginning, which talked about the UK being really good at research in this area, but less good in terms of the way in which it scales up. And I wonder, Dan, you having stepped from CPI into Azotic, have you seen where are the other areas that we need to, or you've needed to partner that aren't, so Alex has talked about CPI, but where have you needed what else have you needed, if you like, in that scale-up journey?
Yeah, so there's many. One of the main ones, Steve, again, back to what we talked about, when the challenges that we face, you put our product in perfect conditions, in lab environments, it works great. We need these collaborations with people who can test our products out in the field, where they're facing these different climates, different soil quality, all these different variables that we can't control in a lab. That's the type of thing that's helping adoption in the market. People want to see consistent results. We can't just continue to provide consistent results from a lab. We need to have partners, again, in our own country, in the UK, in Europe, in Asia, the US, partners that will help us test our products in their facilities in order to create that. We're looking to create the pull from the market for biologics.
Yeah, and so that's something. Obviously, if you're trying to do field trials in other countries, that's obviously something the UK will struggle to provide. But what are the kind of things you both think the UK could do more of to help companies get across this line, if you like, from getting something that kind of has a technology that's starting to look good, but actually it's got to get from where they are now to actually having something commercially viable?
I think this probably leads us into the discussion around funding and money's been available. As we know, scaling up biotech isn't cheap. We talk about a 75% win rate. From an investor standpoint, I'm kind of saying, okay, at the start of our journey, I'm expecting that 25% of what we create isn't a saleable product. Money people and CFOs don't want to hear sort of messages. Funding being available and equipment, and again, a bit like I was just talking about, the right resources, the people. As a working back at CPI, I don't think in my 10 years we brought in an operator who was working in our facilities that knew fermentation. We bring in operators from the Teesside area, and we at CPI at the time, we would educate them and train them in fermentation. That's not something that's readily available at the minute.
So you talked about labour. We'll come on to that in a few minutes. You started to talk a little bit about funding. Alex, in your perspective, what's the funding journey like for somebody who's got a really good idea? The technology looks promising. However, it's expensive, as Dan said, to get from where you are now to make the next move. You've done everything in the lab. You've done it on a shoestring up to now, but you're going to have to scale it. You're going to have to create some quantities of this material. You're going to have to recruit, talk to people, bring people in. How does that look from the outside?
It is an interesting one. I think that the main thing, I think, as Dan's mentioned there, scale up's expensive. You have to back businesses in the right way to allow them to spend the funding they have on the most valuable things they can do. This is quite a hot one for me. We clearly spend a lot of our time working with SMEs who are, looking for scale up support. There are mechanisms that are available to help these companies access the support they need. Something that we generally have in the UK when companies are looking for grant funding, for example, is that there are some rules associated with these grant funds. One example of that is there is a cap, for example, on how much of a bid that a company can allocate to an RTO like CPI, for example, or an academic institution. Most of the time, that's around 30% of a pot. Now, kind of, if you imagine a startup, maybe they've just, sort of mentioned before, a couple of guys have just spun out of a university with a great idea and a small team, handful of scientists. They've got a technology that maybe is ready to be demonstrated at that next scale, but they don't have the equipment themselves to be able to do that, or the people to be able to do that. What they really need then to kind of drive themselves forward is access to that scale and that capability to make it more robust and scale it up and demonstrate it at scale. They need somebody like CPI who has the capacity and the kit to be able to do that. So we go and identify a grant call that can fund that work. But to work with us on that project, though, they can only allocate 30% of that pot to us. So they need to find another 70% themselves, which, if they're needing significant work from us, that could be hundreds of thousands of pounds worth of work they need to identify to deliver themselves with their small team of scientists, just to unlock the funding to access the support they need from us. And also they need to match that as well, because they might not be fully funded. These kind of somewhat arbitrary rules can actually be quite a significant roadblock to some people, to help businesses engage with the scale-up support network that does exist in the UK at the moment. It's an interesting challenge we face.
So as you think about that, Alex, is your sense then, because you talked about the availability of facilities that you have at CPI, is the issue for the UK? Is it facilities, or is it have we got enough facilities, but actually we need more funding? What's your sense of that?
I think it's around enabling the funding in the right way. So it's there is plenty of funding around. Obviously, there's an awful lot of funding that's been spoken about recently, and we're not necessarily underfunding things. I think we're just funding things in a way which is a little bit too restrictive, and potentially isn't the most effective way of doing it. That example of the 30% cap, for example, if that rule wasn't there, say we've got a business needs, simple numbers for simple sake. Say a business needs £300,000 worth of support from CPI. At the moment, they need to frame £1 million project to access that £300,000 worth of support. Alternatively, we could fund 3 companies to deliver that £300,000 worth of support for the same amount of total grant investment. But we currently can't do that. Yeah, so it's not about, I don't think it's about the quantity of money that's available. I think it's around the accessibility of it.
Right. And Dan, as you look at the Azotic journey, where are you in the access to funding world? What's the sort of hurdles you're facing?
Yeah, so what's interesting is one of our barriers, obviously, again, what we've talked about a few times, is the mindset around nitrogen fixing and biologicals. It's some of the mindset is it's not quite there yet. So then from an investor standpoint is, do they want to get in? Investors, they tend to respond to it pretty well, to Azotic as a business, because where we fit in the sustainability agenda and the commercialization and the commercial availability of the business, and the commercial opportunities available. Again, we go back to scale. The scalability available of our product, we're confident of that. It's now just that adoption to the market and the private investment or the investment available to help us grow as a business, not from a technology side, but again, from these trials are expensive. Growing our resources internally, our sales team, our regulatory teams, in order to support the rollout of the business.
And is that when you're looking for money? I mean, Alex talked a lot about grants there, and I assume in the early days that was similar for Azotic. There was access to grants, but I assume the world you're talking about now is a very different finance world to the world of trying to find a grant here or a grant there, is it?
Yeah. I think we're probably a little bit past that now, given where we are in our scale up as a business. So now it's that more private funding is more likely to enable us to grow as a business and as an organisation, to be able to, again, what we want to do is provide our biological products globally. That's not cheap. To have the teams available globally to support growers, to support distributors. We try and do that with the team we have available now. But again, as a business, our ambition is to grow and to be able to fulfill that.
Right. And it sounds like what you were saying there, there's an issue also in just explaining to new investors what it is exactly that your product does and why it's likely to be adopted and why it's exciting to the market, because it's...
Yeah, as you can imagine, Steve, we're talking again, we go back to this is a live organism. We're talking about biologics and how they can help some of the challenges that we face. The investors they're excited by it, but it's getting them on board with what it is and our challenges and how we face and how we expect to come through these challenges.
Yeah, no, interesting. And I think one of the things I want to ask the two of you now, just if you both reflected on the years you've been trying to work with companies, both inside and outside companies, in terms of raising money through grants or raising money through investors, is what would be your advice to the UK government in terms of what it needs to do in terms of engineering biology? So if you take that answer, that bit the House of Lords said, which was, clearly we've got great research in this country. However, to get from great research to where products hit the market requires a real mixture of funding, which you've talked about. What would you do differently? Alex, you first. What would be your one thing you'd say to the government? Here's something I'd do.
I think the big one for me, I think, is back to kind of allowing companies to spend the funding they have available in the way that is most impactful for their own business. Because not every business has the same challenges. Everyone will have to address different things on the way through. And also I think long-term backing as well. It's not a quick process to get a project or to get a product from the lab to the commercial world. What we're seeing as well as a lot of the businesses we work on multiple grant-funded projects over the course of several years with businesses, and they're having to spend a lot of time going and finding the next grant. So actually backing the company, pick a winner and back that company all the way there. Obviously stage gate it. So, if something, something doesn't go right, or it turns out that actually it's not as rosy as it initially looked like it might be, you can stop at some point. But giving people that consistency of funding all the way to the point where they are ready for the commercial funding world to take over, I think will help as well. Let people focus on what they need. There will be technical challenges, there will be business challenges that everyone needs to address, and having to go back out and constantly find the next bit of money is a distraction from that.
I think that's a really interesting point you made there, Alex. Not one I'm sure I've heard many people talk about, where you kind of imagine that on the grant giving side, there's a continuity of interest in a company, such that it's less about the grant giver finding the money to create a competition for grants all the time, but actually also a case of working out how you take companies that are promising and are going forward. How do you get that to work? That's an interesting balance you've then got to get between how you continue to make it an open process to get money, but also how do you continue to take winners and move them on?
I think the important thing we've got to remember from a government funding point of view is there needs to be a return on that funding. And the return on that funding is when you have a successful business, which is making revenue and then paying tax back into the system. So you kind of have to get to the end point, otherwise you never get the return.
Yes. No, that's a really good point. Dan, what would be your advice to the government minister who's sitting listening to you?
Yeah, so I've had a little bit of time to think while Alex was talking. Mine would be a little bit more selfish from an Azotic standpoint. Mine would be to help us create that market pull. What we have constantly tried to push biologics. If the government could help us create the pull, if they could help by adopting biologics into their procurement or the things that they do, this helps, again, Azotic, it helps all of Alex's customers to create that supply chain into the market. Again, we're working globally now. We speak with different countries and different distributors in different countries. And what's happening is some countries around the world are setting ambitious targets where they want to reduce the usage of synthetic nitrogen fertilizer. An ambitious target by 2035, we're going to reduce by 25%. It starts to get these distributors, these growers thinking, what do we do? It helps companies like Azotic to then fill the gap. We can work with distributors, we can spend the time, we can do the education, we can onboard distributors, and we can create the pull from the market.
Well, that's a really interesting thought. And so from a barriers to actually implementing that, what do you see as the biggest barrier, if you like, towards a government moving in that direction? Which is it something that you would expect the government to be able to do, or is it something that, because it sounds like, you're talking about multiple departments here, because you're over in DEFRA, presumably starting to talk about how you run an environmental policy, or how you really, to get market pull in the way you're talking about, it requires a sort of multi-department approach within government that's notoriously difficult to get right.
It does, but on the other hand, we all know we have a food security issue. So it's what do we do? And again, you see some of these countries where they're starting to put these implications in now, where we should start to look to find ways of reducing health pollution and all these other challenges that we face. And then again, it starts to create the market pull. And again, together then as with collaborations and everything else, we start to fix that issue.
Yeah. So we start talking about engineering biology, and of course, what you're doing is you're taking us to a point where you hit the market. Of course, engineering biology starts to become something that you've stopped talking about. You're actually talking about solutions that are changing, have an opportunity to change the world, don't you? So that's a really good. I think it's a really good segue into some of the things we're we've talked about, and some of the things we're going to talk about later as well. Which thanks for that, Dan. I'm interested. Both of you have come at your careers have been different. You talked, Alex, about your switch over from the more heavy industries, and Dan, you talked about the career you've had in terms of starting with CPI and then moving into Azotic. Skills and training and availability of skills continues to be one of the biggest issues in this area. Do you have a sense of what the level of importance is for this? Where we've talked about funding, we've talked about market pull. Where does skills and training fit into this? Alex, perhaps you go first.
I think it's huge. We always say it's not about the equipment; it's about the people. You have to have people that understand these types of processes. Dan mentioned earlier on, when we bring in our own operations teams to run our scale-up facilities at Wilton, we tend to be taking people out of non-biotech backgrounds and then having to train them up ourselves. So having a broader understanding of how you operate biotech processes is it's important. Yes, it's definitely a big thing. Yeah, I think it aligns. I think it generally with there's a general shift in industry across from traditional old school foundation industries or process chemistry based processes across to bioprocess and to a little bit more novel processes as well. It's a different skill set, so that there's different training required, different backgrounds required, different skills required.
Dan, you talked about taking process operators from Teesside, of which Teesside's blessed with quite a good supply of people that are in process industries. But how do you get somebody who's perhaps understands a little bit about what it takes to make stuff? How do you get them to become biotech or biomanufacturing experts?
Yeah, again, it's difficult. It really is difficult because it's a complete different way of working. And one of the difficult challenges that we face as well is the failures, the work that goes into preparing and running the fermentation. And then we see that we've got contamination. The work that you've put into that process and to get to where it is, and then you find out that there's been a contamination along the way, and actually, you know what? It's going in the bin. It's from a morale standpoint, it's difficult from within the team. And we've faced a lot of challenges over the years. But you've got operators from an Azotic standpoint. We've got many different resources that are required that are difficult to find. So you've got the amount of regulatory challenges that we face, and you're working then with biologics. Getting biologics shipped around the world globally, it's difficult. Getting the registrations, understanding the different country requirements in order to get them registrations, and then we face other challenges for example, formulations. We, again, with the help of CPI and the collaboration we have with CPI over a long time, we get the fermentation, but then what? Once it goes out the fermentation, then what do we do? How do we formulate it into a product that the market are demanding?
I think it's interesting the way you've talked there about regulatory, and then you talk about some of the downstream needs within the processing. Alex, you talked a little bit there about the general issue as well of the difficulty, if you like, of getting people who've got this expertise. One of the things that strikes me as always is that people who are outside the industry struggle to even recognize job titles that they would actually be capable of doing. And I don't know if you recognize that, and what you would advise somebody who's sitting outside this kind of industry. What kind of experience would help you come into the biomanufacturing business, if you like, and that's the greater business, if you like, of engineering biology and making it a company happen.
So that's an interesting one. And that just you mentioned the not recognizing job titles. Yes, that is a challenge. But I think mostly it's just there are a lot of transferable skills. It's a lot of the same. It's a lot of the same thing, just applied in a different way. So yeah, we have, as we keep saying, look, we've brought people from completely different backgrounds, and they are now, our plant's full of them. They're all great. They are delivering fantastic work on our facilities. It can be done. It's just that understanding how to apply the skills you've already got into a slightly different world. So it's not something people should be worried about or scared about. It's a good opportunity to add a different skill set to your CV.
So you're saying, Alex, people shouldn't be put off by the fact that you've talked about biomanufacturing and engineering biology being quite difficult in certain areas, but actually the transferable skills they've got in other areas will definitely help them in terms of things that are on the floor.
It's just applying skills you've already got, knowledge you've already got in a slightly different way. It fundamentally, I was, my background as an engineer, I used to talk ourselves down a lot and say it's just moving things from one place to another and heating them up and cooling them down and mixing them. It's still fundamentally that. It's just done in a much more controlled way.
Dan, academically we're very strong in this country. What do you think there's a role for academia to play here in terms of the supply of skills to the engineering biology businesses?
Absolutely. Just following up on what Alex is saying, for me, it's that being curious. All I ever tell the people working with me and around me is just be curious. Just ask them next question. Innovative thinking is key, because the challenges that we face, there's no right answer. We're all out there trying to find the right answer. And the skill set, it's the range of skill sets required. I think like what Alex is saying is, we're in the lab working at really small scale, doing multiple experiments to try and get the right recipe to transfer it then into a larger scale operation. We're talking about now scalability. The range of different resources required to take that process from a 10-litre fermenter to a 10,000-litre fermenter. We go from a team with a very, very different mindset in the lab to a team in our operational plant areas. And that tech transfer of the process all the way through. And again, it's important to have that range of resources available.
I want to move you on a little bit, Dan, to think about the Azotic journey that you've joined into from 2019 to now. What were the biggest hurdles for Azotic in terms of getting from where it's come from to where it is now?
So initially, it starts in 2019 when Azotic approached CPI. And at the time I worked at CPI, I worked with the guys from Azotic, and we took it from a 10-litre fermentation to a 10,000 pretty quick. We got it into the market pretty quick. And then we start to learn more about it. We start to understand more about our product, how we can formulate it different, and all these other things. The challenges, it's again what we talk, it's the adoption of biologics within ag-biotech, like within agriculture. It's a very traditional market. So to introduce biologics is difficult, coupled with the regulatory challenges of getting into these different countries.
And maybe so if we sit at the other end, then you talked earlier about creating a market pull for your product. How do farmers go from where they are today to being a partner of Azotic then? What's the sort of process you have to take them through to get their heads around it?
So we work a lot with distributors, but what's key is us working with the distributors to make sure that they understand what it is we're trying to do. They understand our product and they're bought into it. We're trying to create these partnerships with distributors so that they work so closely with us. They understand the challenges that we face. They understand the wins that we can create and the commercial opportunities. I think it's really important that we work really closely with these people. But again, that's really difficult. From a funding perspective, from an availability perspective, it is difficult.
And are the distributors the closest you get to the farmer, or do you spend, do Azotic also have to work out how to help a distributor persuade a farmer to take on the product?
Yeah, in some countries it's very different. In the US, we've got some really small team, but again, we try to have our resources out there talking to growers. We do trade shows where we're talking to growers and trying to educate them and onboard them with biologics and what it is that we can do. Again, back to the field trials, we have to be able to create the data and like I say, it's in that country, to create the data in the country for the US on corn to create that pull.
Yes. Yeah. No, I can see that. That's and that's one of the problems with any new technology of this kind. And engineering biology is part of the story, isn't it? But actually, wherever you're doing a transformational new technology in the market, you've got to overcome that and get real world examples of why it works and others. Alex, I wonder if, as you've watched Azotic's journey, what have you pulled out from Azotic's journey that you then share with others and make it easier for others to follow in the footsteps that Dan and his company have gone in?
For me, I think the main thing is the example of collaboration, and I'll keep using that word of finding, picking out the thing that you're really good at and focus on the thing that you're really good at and do that really well. Recognize where you have gaps and build a network of other companies and collaborators who can help you to fill those gaps. That's the most effective way to get where you need to get to allow yourself to focus on the things you know you can do well. Sometimes people do try to take on a little bit too much and end up kind of almost not being able to deliver the thing they do really well because they're too busy trying to do something that's not really their strength. So Azotic is a really good example of focusing on the things they do really well and putting a network of collaborators around themselves that can help them with everything else. So you're both pretty optimistic about this world, and who wouldn't be? But you two are proper optimists in terms of getting this, getting engineering biology adopted in the marketplace, taking people on a journey through that process. What do you think is, as you look forward, what are you most excited about in terms of what can be scaled up, what can be done with engineering biology? What are the, particularly in ag tech, Dan, from your world, what's the vision? What's Azotic's vision, and what do you personally think for ag tech from an engineering biology point of view?
It's to create security, both for farmers, but for food security but also creating jobs. Again, if I jump back to the resources point, one of the things I missed off was the fact of apprenticeships. I'm really big on driving apprenticeships. 30% of our workforce currently manufacturing our products are of apprenticeships. What we're then now trying to do is create roles for people in a different sector that again is growing. And with market pull and adoption globally, let's see where it goes.
No, that's really exciting in terms of, and particularly with the jobs side to that too. In terms of just helping to think about from a productivity point of view. I mean, if you come to Teesside, you can see, fertilizers have been in the blood of Teesside for decades. What would an Azotic world look like? Is it the end of chemical fertilizers, or is it, how does a world look with Azotic products adopted?
We support it. We support it and support the reduction of, to help with against pollution, all these things, but create a world where the need isn't as high for synthetic nitrogen fertilizers. I don't think where biologics are going to ever, in the next 5-10 years, take over. And it would be very bold for us to sit and say, we're here to take over, because that's not what we're here to do, is to support and help. Again, if we increase yields for farmers, create the food security.
Right, thanks. Alex, similar question to you. in terms of the next frontiers, if you like, of where the sorts of engineering biology, the applied engineering biology, if I can call it that, in terms of the technologies you see coming, things that CPI is looking at today. What are you most excited about? What are the things that you're seeing as being possible over the next 5 to 10 years?
It's difficult to pick out specific sort of technologies or areas because there is just so much going on, and I think that there's so many different industries and markets and technology areas where people are having great ideas at the moment of how we can apply engineering biology as a foundation technology to do things differently, and to help, as I said, similar to what Dan was saying there, supplement and enhance the existing ways of doing things. I think there's a lot of opportunity for more environmentally sustainable processes out there, but also processes that are have to be financially viable as well. So help them to create businesses that can help to take the world forward. That's a very sort of.
What do you think? And just on that, Alex, what would what are the common factors for success then? What are the things that you think of when you look at those that you've just identified there? What is it that'll make them successful?
For me, it's the marrying up of, it has to be a technically good idea. It has to be a technically good idea, a good process that there is a market for. That it has to be. We always say this. One of the examples I always give is one of the very first things the first questions I was asked as a graduate engineer when I first joined in the iron and steel industry. They asked me, what does a blast furnace make? And I naively said, iron. And they said, no, it doesn't. It makes money. And that's that. You always have to have that at the front of your mind. Whatever you're doing, however interesting and fantastic your technical idea is, there has to be a market for it. There has to be people that are interested in buying it. And it's as well that there's a difference as well between it being technically commercially viable and it being acceptable to industry, and that's another key one. Is there are some potentially really interesting concepts out there that you just think, right, okay, if on paper it's technically financially viable, but would the market accept it? And how do we do that communication of making sure that there is a market available for something when it gets there? That focus is always the key one for me, is keeping an eye on it being a financially viable proposition all the way through. Yeah.
Dan, same question for you. What do you think? What are the common ingredients for you as you look forward in terms of both for Azotic but also for other products that you see that are promising?
Yeah, again, it's just it is a difficult start, but once it gets out there and once you start to see the success, I always say, people around me don't understand biotechnology. My family, my friends don't really understand biotechnology. They're what is it you do? And the first thing I do is to show them photos of where our product is helping increase yield. This is what we can do. This is our ability. We're just out there trying to do it.
Yeah, I love that. And I love the fact you've got the experience, the sort of photographic evidence of where it is making a difference. I think that's, to me, if I picked out a couple of things you've said, one, I really liked what you said about, people who are curious, coming into the industry. No matter where you're sat today, whether you're at school, whether you're in university, whether you're already mid-career, I think curiosity and a desire to be in industry that makes a difference, because I think you can take some of what you've been saying there really, really strongly about products that you can show farmers that are actually more resilient, more product, getting a better productivity out of what they're doing, getting better yield, and back to Alex's point, making money doing it. I think if you put those two together, those ingredients together, you kind of put together what the engineering biology world looks like, don't you? If you're in 5-10 years time, where have we got to? Those are the kinds of things. want to ask you a final question about UK. Where do we stand versus the world in this? So we've talked about the excitement there. Alex, from your point of view, are we people have worried about it being a research heavy place rather than being somewhere where we actually manufacture these products? Both of you are in worlds where you're trying to get to a manufacturing world. What's your one thing for the UK to get us there? To actually get us to be a place where engineering biology manufacturing is something that's happening?
That's a very big question. Yes, I think that's where we do see that there's challenges there. Obviously we've supported businesses, for example. If we look back at Callista, for example, as a business we supported for a very long time. We work with them to scale up and demonstrate their process at sort of demonstration scale on our facility at Wilton. We ran with them for several years. They got their investment to go and build their commercial facility, and then they went and built their commercial facility in China. And that's I think a lot. Well, obviously that's their business, but I would expect a lot of that was down to cost. And that's because when you get to that scale, when you get to full production scale in a business, the number one thing you're looking at is cost. So that's where it's kind of as simple as that. It needs to be cost effective for people to run manufacturing businesses in the UK, and that's things like that's energy costs. It's tax rates. It's all sorts of things like that come into it. It has to be an attractive proposition to create a manufacturing business in this country.
Yeah, no, great. And Dan, what in terms of looking forward, what does an engineering biology UK look like?
I couldn't agree more with what Alex just said. Again, being part of Azotic, which is a small team, the UK, we sell into the UK, but it's not our biggest market. Why then do we manufacture in the UK? Why would we not move to one of the countries where we manufacture, where we sell the most? We've got the experience here. We've got the technology understanding here. We've got the skill sets of the people we need here. That's why we're manufacturing currently in the UK. We will continue to do so until decisions are made by the business to move, or I just hope that with the help of the government, with the help of, again, we've got rising costs of energy. It makes things difficult. I just hope that we can continue to manufacture in the UK.
Thanks. Well, thanks to both of you. It's been a really inspiring, thoughtful journey through engineering biology, and particularly the perils of scale up, but also the opportunities and also the positive uplands when you get there in terms of where you've reached. It brings us to the end of today's episode of People in Innovation, a CPI podcast. We've explored and gone through the themes of scale up and some of the things that makes the UK a great place to do it, but also some of the things that worry us about the future in terms of how you continue to scale up and create a place where indeed engineering biology is adopted as a means of manufacture as well as just for research. We've talked about how we get people excited, bring curiosity with you, come and join engineering biology companies. How do we get those people into our industry? And we talked at the end there about some of the trials and tribulations, if you like, of what the next 5 to 10 years will hold as companies scale up. A big thank you to my guests, Alex and Dan, for joining me. Thank you for listening. If you'd like to learn more about CPI and its work in engineering biology, visit uk-cpi.com. And don't forget to subscribe so you can watch the next conversation in this series, where we'll be exploring how engineering biology is being used to rewrite the code of life, and practically how it brings hope to those who have life-threatening rare and ultra-rare diseases through the development of advanced therapies. But until then, stay safe, stay curious, and let's innovate together.